All right, guys, so we're going to move forward a little bit. We're going to talk a little bit more about unit rates, and we're going to start talking about proportionality. Okay? So we're going to have some instruction in class about this too, but let's look at some things that let's just review some things. So you should be able to do these two problems on your own, right? So go ahead and in the next 3 minutes, just hit pause, set these two problems up. Let's see if you can do those. Okay? All right. So you're going to compare unit rates, which one's the lower price per pound, and you're going to look and see if you can come up with a unit rate for the bike ride. Okay, go. Okay, so you should have been able to come up with this and seen that you wind up with, for the 3 pound bag, it winds up being $1.38 per pound, and that for the 2 pound bag winds up being $1.43 per pound. So the cheaper price is the 3 pound bag, which is because that's $1.38. Is cheaper than $1.43. So your answer would be right here, right? That the 3 pound bag of flour has the lowest price per pound. Notice that when we write out our answer, all we're really doing is just rewriting that sentence, plugging in the value. Okay? We're just taking the question and now making a statement out of the question. Okay? Now for Phil, it's miles. How many can he buy? Miles in 1 hour. So that means miles is the same thing as saying per right here. Okay? You might, that's a good one to take note on, right? So we're talking about miles over hours, right? So we're looking, setting it up. Then we plug in our values. So we had 4 miles and 3/5 of an hour, right? And so we put these values in, and then we simplify. So we would have taken 4 divided by 3/5, which means we're going to take 4 over 1 times the reciprocal, which is 5/3, which if we multiply straight across, we have 4 times 5 is 20. 1 times 3 is third. So 20/3, which would be an acceptable answer, but doesn't really help give us a good idea. So again, that becomes 6 2/3. So we have 6 2/3 miles per hour is how fast he's going. In 1 hour, he can go 6.23 miles. Okay. All right. So that's about as fast as a good runner. So, okay. So now let's move on. Okay. Now we're going to be talking about proportionality. So what we're going to do is, here's the rule of thumb. Things are proportional if they have the same unit rate. Okay. You should write that over here on the side. If it's a proportional relationship, they will have the same unit rate. Okay. Write that down over there. Okay, so just write that down in your notes. Okay. And so when we're comparing them, right, we're going to look at these and we're going to do each one of these pairs, each one of these ratios, this ratio, this ratio and this ratio, we're going to write them out as a unit rate. And if they have the same unit rate, then it's a proportional relationship. If it doesn't have the same unit rate when we compare each one, then they're not proportional. Okay. Now we're going to look at it says price per pound. So this is really important because some of you are already looking to see what you could do, right? And some of you are going to tend to look at the top and divide it by the bottom. And even though you come up with the right thing, you won't have the right unit rate. Okay, and that's really important for what we get to at the end, is that you know how to figure out the unit rate. So one of the things I'll talk to you more in class about this, but we're always looking at, you've been talking in science about independent or dependent relationship or variables, right? If you have a dependent variable, then one of them is a dependent, one is an independent. One of them happens and the other one is caused because of the other, right? So you have to ask yourself in this situation, does the amount of tuna determine the price, or does the amount of tuna depend on the price, or does the price depend on the amount of tuna? And what we know is that the more tuna we buy, the more we're going to spend. So the price depends on the tuna. So the dependent variable is always going to be the y, right? And so we're going to call this our y variable and this our x. That's really important for you to understand this. And what we're always going to do for our unit rates, we're going to say y over x. Okay, so when I look at this, I'm going to ask myself, well, so for 2, that's going to be $10 for 2 pounds. For 4 pounds of tuna, right, that's going to be $20 for 4 pounds. Okay, and then for 9 pounds of tuna, we pay $36 for 9 pounds of tuna. We want to make these a unit rate, right? You just practice making a unit rate. So this becomes, for the 2 pounds, we wind up paying $5 per 1 pound, right? For the 4 pounds, we wound up paying $5. That's looking pretty good, right? It's looking like it could be proportional. And then if we look at this one, we take 36 divided by 9, that's going to be $4 per pound, right? So this is not a proportional relationship because these aren't all equal, right? These are not equal. Now, 2 of them are equal, but the last one, and sometimes that happens after you buy so many pounds, they start giving you a lower price, right? That happens in all kinds of things. Talk to your parents about it. So we can't predict how much 25 pounds would cost because it's not proportional. So you leave that part blank. If it asks that and you can't see it's proportional. So your question was, is this a proportional relationship? All right. Is it the same or different? Well, they're different. So this is not proportional. And you're going to justify your answer, right? Because they don't have the same unit rate. Okay, that's it. That's your statement. You're going to say it's not proportional because they don't have the same unit rate. Boom, done. Okay. All right, and so you can't do anything with it. Now, so then look at this one. Is this a proportional relationship? Is it the same unit rate of money earned per hour? Okay, so they tell you what this is per, right, hour. So this is the money earned is our Y, and the hour is our X, okay? Whatever's because we're always going to have Y over X. You got to remember that. That's really important for what we're doing. It's really important for when you get to slope and in 8th grade. You got to understand that relationship is always Y over X. And the money earned is our our dependent variable, and the number of hours we worked is our independent variable. So x is, this is important when we're graphing it, which we'll talk about later. Because when we graph, this is always the x-axis, and this is the y-axis. Our x-axis is always our independent variable, okay? Okay, so now what you have to do is write these down. So if that's true, and you're going to do y over x, I would write this down if I were you, just to make sure you're doing it right. So this first one is going to be 37 over 2, $37 over 2 hours, right? And then we're going to write out these other two. Write those other two out. Hit pause. Write those other two out. Let's see if you know. Okay, so now that we have this written out, now we're going to give the unit rate, right? So now write out the unit rate, and I'm going to ask you on the quiz which one of these, what the unit rates are for one of these. So make sure you have it written down, and then figure out your unit rates. Okay, so what you should have seen was this first situation, right? Came out to $18.50 per hour. Second situation came out to $18.50 per hour. And the last situation came out to $18.50 per hour. So they all have the same unit rate. And since they all have the same unit rate, it's a proportional relationship. Okay, so it comes back to this. If it's a proportional relationship, all ratios will have the same unit rate. Okay, and all of our ratios here did come out with the same unit rate. Okay, so we could say this is proportional, which means also we can predict. Because if you're making $18.50 per hour and you work 23 hours, well, we're just plugging this in, right? So we're going to say, we're really just looking at a ratio that says that if we're making $18.50 for 1 hour, how much are we going to make for 23 hours? Okay, so we're still talking about, we're just writing out our units, and we're talking about dollars per and hours, right? I'm going to keep this going. If I look, really, I'm going to use, you could use a number of ways. By the time we're done with this chapter, you'll know 3 different ways to do it, but really, we're just going to use scale factor and say this is times 23. So this must be times 23. So you calculate what 18.5 times 23 is. And what you wind up with is that for 23 hours, you would get paid, you plug that into your calculator, $425.50. Now your calculator leaves that at 0.5, but remember, you're talking about 50 cents. So you got to put that 0 in there, okay? Because you got to round it to the nearest hundredth, right? And so your answer would be, we predict he would earn $425.50 for working 23 hours. Okay? Okay, now if you're looking at this and you have any questions, you should be writing down those questions. So we look at this, we have a situation where they weren't proportional because they didn't come up with the same unit rates. So we can't predict. Not at your level. Next year, this one there isn't a prediction that I can see. Okay, but eventually, next year they're going to talk about if it's not proportional, but there's still a relationship. But right now, we're just talking about a specific type of relationship, and that is this a proportional relationship? Okay. All right. And so what we see is this one was not a proportional relationship. On example 3 is not a proportional relationship, so we can't predict. Okay, and example 4 is it is a proportional relationship, so we can use that as we can use that unit rate, that common unit rate, to predict other amounts, okay? And if we can do that, then we can use, this becomes what we're eventually going to call, this is our constant of proportionality. Because it is a proportional relationship, and there is a constant rate, so we're going to call that K. I'm not going to go into that much more, other than that's going to be called the constant of proportionality. These problems have a key phrase in them. Okay, the key phrase is at the same rate. As soon as you see that it says at the same rate, that means it's a proportional relationship. And that means we can use what we talked about here in this problem. We can use that same principle here. If they tell us it's proportional, here we determined if it was proportional by checking to see if they had the same unit rates and then going from that to predict, right? All this is saying is, hey, this is a proportional relationship. Now you have to predict, okay? Okay, so if you think about this, then what we're doing is we're going to have a unit rate of dollars per hour, right? And what they're telling us is that we have $221 for 13 hours. Okay, so there's two ways to do it. By the time we get done, you'll be able to see two different ways. I'm going to show you this way right now, and that is to say, well, then I got to figure out my unit rate. So what that means is I need to figure out what 1 hour would cost, right? So that means I'm going to divide. I'm going to take and divide. To get 1, I got to divide 13 by 13. So that means I also have to divide 221 by 13. Now at this point, you can use a calculator or your multiplication table. Your multiplication table will show you this, because that means this is $17 for 1 hour. Now they want to know what would we make in 11 hours, right? So we're going to say equals 11 hours, and we got to figure this out now. How many dollars would we make in 11 hours? So if we look, what we have to, the scale factor is 11, right? We're multiplying this times 11, which means we got to multiply this times 11, because we figured out we're getting $17 in 1 hour. So now we do that math, and we get that we're going to make $187. And so then your answer would be that he would make $187 in 11 hours. Okay? All right. Let's look at this next one. So let's see if you can follow the same pathway with this next one. So you try to set this one up. Remember, we're talking about unit rates, right? So we're going to set it up first and identify what our variables are, right? And then you're going to set the first one up. Then you're going to figure out your unit rate. And then you're going to apply that unit rate to what they ask you to do. And they tell us that we're going to go 17 miles in 13 hours. So I'm going to just give you the hint. You're going to go miles per hour, right? Okay, go ahead. See if you can follow the same steps. Okay, so again, you would have written out your original numbers, right? And then you would have come up with your unit rate. And then you would have applied the unit rate. Now this time they give me the miles, right? So I had to figure out 55 times what gives me 385. And 55 times 7. So I did division, right? And so that gives me 7, which means it's going to take me 7 hours. So your answer would be, it will take him 7 hours to drive 385 miles. That's your answer, okay? when we're looking at the answer, that's communicating. You know what you just found. You're not just crunching numbers. You're saying, I know, I just solved the problem, and here's my answer to it. Okay. All right, and we're going to kind of introduce these. These two are pretty simple. We talked about the fact that if you have a proportional relationship, which is what we've been saying here, if these two ratios are equivalent, then it's proportional. Then we would be able to say that A times D equals B times C, right? So we're going to build off this, but right now we're going to look at these two, and we're going to try to solve these two relationships, okay? So one way that I can solve this proportion, right, because that says they are equal. So one way that I can solve this proportion is I can first simplify this fraction, and that might make my life easier, right? And if I look at this, this is 3 times 7, this is 3 times 5, so the 3's factor out, and so I can rewrite this as 7 over 5 equals 14 over n. Now, if I look, this method's called scale factor. I know that I can take 7 times 2 to gives me 14. So 5 times 2 must equal n. So really what I've just said is 5 times 2 equals n, and 5 times 2 is 10. So n equals 10. So what I'm looking for is that n equals 10. I've solved it. Okay, we've looked at this, and you know how to solve an equation. So why don't you plug this one in and see if you can solve it, and then we're done. Okay, so if you solve this, you should come out to that P equals 105. So if I just look simply that 12 times 36, 12 times 3 is 36. So I'm going to use scale factor here also. 35 times 3 must equal P. 35 times 3 is 105. Now, when we're in class, we're going to talk about how you could, being aware and looking at how to predict your answer. This is all you have to do with this. So, right. So this is what we're going to be talking about in the next couple of days. This is really important that you understand. Make sure you're getting how to do this. You're coming in with questions. See, we're applying the math now. So that makes it a little harder, and you have to show your answers and your solutions. Okay, good luck.